Hi and welcome to Business Statistics Revision Session number 2. In this particular session, we are looking at June 2019 final exam for CA Zika Business Statistics. June 2019 paper. So let's go to that question paper. Just see this is June 2019 final exams for CA 1.2. CA 1.2. So let's go straight to the questions. Question number 1. An economist assesses the economic performance of organizations, households, and the nation by obtaining various forms of data classified as continuous numerical variables or discrete variables. Which of the following can be classified as discrete data? So classified as discrete data is data that you can only express in absolute numbers, meaning that in discrete data there are no decimal points. For example, if you're talking about number of people, you can't have decimal points when you're explaining number of people, because it's not possible that you can have a point something, point somebody. For example, you can't have 7.8 people in a place. You can't have a point something person. So number of people, number of items, all that is discrete data. Continuous data is data that takes on any variable, meaning that decimal points are also allowed. So if you're talking about weight, height, time, all that is continuous data. So if you look at the options, option number 1, units of inventory, items of inventory, length of time, obviously that one is absolutely continuous. The average number of persons cannot be continuous. Then the average annual income is continuous. So if you are eliminating some of the options, B and C are quite explicitly eliminated because that's obviously continuous data. The debate can only be on option A, number of items and the number of persons. All right, so if you were choosing number of persons, average number of people, definitely you can't have decimal points for people. You can't have decimal points for people. So the correct option is option C. However, option A is also debatable because number of items can be expressed easily in discrete data. You may not have decimal points of a number of items, but the express one you can go for here is option C. Next, question 1.2. A financial service provider estimates the probability of the number of days required to complete a loan application, X, for customers who have no consistent salary and have no pay slip, as shown in the table below. What's the probability that X is greater than 2? Greater than 2 days. 2 is not included, so greater than 2 you start from 3, 4, or 5. And again, you can't complete those applications in 3 days and 4 days and 5 days at the same time. No, it's either you have 3 days or you complete it in 4 days or you complete it in 5 days. So these events are mutual. You should apply the simple addition rule. So simple addition rule, you just had the probability for completing in 3 days plus the probability of completing in 4 days plus the probability of completing in 5 days. So 0.23 plus 0.35 plus 0.29. The answer there, the correct answer should be 0.87 when you had those three probabilities. Next question. All right, so from the table of quarterly magazine sales given below, calculate the centered moving average trend value for the fourth quarter. Now, periods are given in 4 quarters of the year, so you can use the 4-point moving average, and you are calculating the centered moving average. Now, you are calculating the centered moving average for the fourth quarter of 2014. So you're looking at this quarter. So in a 4-point moving average, you just have to go 2 values or 2 quarters further than the fourth quarter. So you can get data up to second quarter of 2015. So you get 112, 145, 164, 123, 132, and 161. So your table should look something like this. Okay, so you have those 4 quarters, the total of 6 periods, but you're looking at the moving average and the centered moving average. So when you get the average for the first 4 values like that, get an average. The average you get there, you put it right in the center, right in the middle of those values. And so adding 112 plus 145 plus 164 plus 123 divided by 4, you should get 136. So you put 136 there. Not there, obviously. You put 136, it's here, the middle of that, that's 136. Then you had the next set of 4 values. Those are the 4 values, and the mean you put it there. So those values added together divided by 2, you should get 141. Then you had the next set of 4. That's the next set of 4, and the value you put it right in the middle there, and that mean should be 145. Now centering this, you are getting the mean of the 2 values like that. You're just aligning the moving averages with the particular quarters of the year. For example, 136 has a moving average, has no corresponding quarter. 141 has got no corresponding quarter. So when you get the average or you center them, that's when you are going to have a value that will correspond with quarter 3. And this value should be 136 plus 141 divided by 2 should be 138, 138.5. Then when you get 141 plus 145 divided by 2, that should be 143. The question is saying we get the centered moving average for the 4th quarter of 2014, and so the 4th quarter of 2014 will be that value there. You can just put it in bold, that value there. So the answer should be 143. So let's get back to the question. 143, that's option B. Now the score of the mathematics examination results at Zika for 12 students given as follows. Calculate the mean score. The mean is the sum of those values divided by the number of values. So you had 65 plus 90 plus 57 plus 71 plus 57 plus 83 plus 59 plus 82 plus 66 plus 70 plus 82 plus 90. Then you divide that sum by 12. When you do that, your answer should be 73. So the correct option there is option B. All right. 1.5, in regression analysis, the variable that must be a random variable is the variable that is unknown. The variable that is not known actually is the variable that you are calculating, and this should be a dependent variable. Dependent variable is the variable that you do not know, is the variable that you are calculating for. So option B is the correct answer for 1.5. 1.6, if 75% of questionnaires distributed in a survey are completed and retained, what is the chance that a questionnaire chosen at random is not retained? So if you are retaining 75% of the questionnaires, it means you are not retaining the 25% of the questionnaire. So the probability of not retaining is 1 minus the probability of retaining. So 1 minus 0.75, the answer is going to be 0.25. So the correct option on 1.6 is option B. We move on. Family income is normally distributed with the mean 25, the variance of 16 million. If the poverty level income is below 15,000, what percentage of the population lives in poverty? So what percentage of the population lives in poverty? You may need to do a bit of calculation on this one. I will do the normal distribution curve so that we just have an idea of how to work out this one. I hope I'll be able to draw a nice one. Okay, so let's say that's our normal distribution table. The mean is halfway. Is found exactly halfway of this table. That's the mean there, and we are told that the mean is about 25,000. The mean is about 25,000, so we know that that value there should be 25,000. Then the other thing we are told is we are looking at those who are earning below 15,000. 15,000 should be on the left side of the mean. Let's say that's our 15,000 there. So 15,000. Then the other one is okay. So let's just flash back to the question and see what the question is talking about. If the poverty level is below 15, so what's the percentage of those that are earning below 15? So if the poverty level is below 15, you are looking at the area on the left side of the mean. The area on the left side of the mean, like that. That's below 15. So how do we work out this? You need to calculate the z-score, and we know that z equals to z equals to x minus mean divided by standard deviation. X minus mean divided by standard deviation. So what's the value of x? The value of x is 15,000. That's 15,000 minus the mean. The mean is 25,000 divided by the standard deviation. Standard deviation is the square root of the variance, square root of the variance. So if the variance is 16 million, what's the square root of 16 million? So let me just get it on my calculator. So 16 million square root okay, so there we go, square root of 16 million. 16 million square root, that's 4,000. So this will be divided by 4,000. So now let's get the value for that to 2 decimal places. Okay, so 15,000, that's 15,000. 15,000 minus 25,000, that will give us a negative 10,000. So negative 10,000 divided by 4,000. That's 2.50. That's a negative 2.50. So when you get that value, you have to go to the normal distribution table to find the corresponding probability for that value, and that probability you are getting is the probability or the area between 15,000 and 25,000. So using the normal distribution table, you go to row number 2.5, row number 2.5, and column 0.00. The value you get there should be 0.4938. 0.4938. So what that means is that the value between 15,000 and 25,000, that area on the graph, this area here, that area is 0.4938. So the area below should be 0.5 minus 0.4938. So you get the probability of x less than 15,000. Probability of x less than 15,000 probability of less than 15,000, that's going to be equals to 0.5. Why are we taking the 0.5? We know that this entire half of the graph here is 0.5. So that's 0.5 minus this area. What remains should be the area on the other side. So this minus the 0.4938. So 0.4938, this will be, so you get the 0.5 less 0.4938. That will be 0.0062. 0.0062. And that will translate into a 0.62% of the people living below poverty level. So let's get back to the question. So we check the correct option there. On 1.7, correct option should be D, 0.0062. All right. Given a sample of salary in quarter structure of company A as follows. So those are the salaries. Calculate the coefficient of variation. Now, coefficient of variation is the mean divided by, is the standard deviation divided by the mean. Coefficient of variation equals to standard deviation divided by the mean. So you get the standard deviation divided by mean. That's the coefficient of variation. So what you need to do for this question is you need to get the mean, calculate the mean of those values by summing the values up, divided by the number of values, and also calculate the standard deviation. When you divide those figures, you must get 62.36%. 62.36%. It's an easy thing to do. Get the mean and get the standard deviation of those values and divide those two. Next question. In regression analysis, the coefficient of determination ranges. The coefficient of determination should range from -1 to 1. From -1 to 1. So the correct option there should be the coefficient of determination, not the regression. Sorry, not the correlation. Correlation ranges from -1 to 1. Coefficient of determination is the correlation squared. The correlation squared. So that value would only range from 0 to 1. You see, when you take the negative value and you square it, it will turn into a positive value. So if you are talking about the coefficient of determination, the range is from 0 to 1. If you are talking about regression, or if you are talking about the correlation itself is from -1 to +1. Coefficient of determination is the correlation squared. So the correct option for this question is option A, from 0 to 1. Please take note, it's the coefficient of determination, which is the error squared, and not the error itself. The error itself ranges from -1 to +1, but the error squared will only range from 0 to 1. All right, so let's look at the last one there. Which of the following is an example of quantitative data? Quantitative data is data you can express in numbers. The opposite of that is qualitative data. Qualitative data, data you can't express in numbers, because that data talks about attributes. So if you look at gender, ethnic groups, and one's state of residence, all those are talking about attributes. Age is the only data you can express in numbers, because you can talk about how old are you, 17, 20 years. You can express age in numbers. So age is the quantitative data. So the correct option there is option D. Let's move on to section B and talk about those questions for section B. Okay, so in a box you have 8 red, 5 white, and 7 blue balls. 3 are drawn at random without replacement. Find the following probability. Find the probability that all of them are red. Okay, so let me just pick this question, transfer it to the answer page so we can look at it from that angle. All right. Okay, so find the probability that all of them are red. You're looking at the probability of the first one being red, the second one red, and the third one red, because you are picking 3 balls without replacement. And so that probability would be, if we have 8 red balls out of the total number of balls, the total number of balls in that distribution will be 8 plus 5 plus 7. That is going to be 20. So picking a red ball at first would be 8 out of the total number 20. Remember, the probability of any event is number of ways you can have that result divided by the total number of possible outcomes. Number of ways you can have a desired result over the total number of possible outcomes. So that's what we have there. So what's the probability of picking the second one? Now the question is saying without replacement. So without replacement, if you picked a red one at first, you will remain with 7 red. Since there were 8, you pick one, you did not replace it, so you should remain with 7 red balls, and the total number of bows shouldn't be the same either, because you didn't replace the first one. So if they were 20, you now remain with 19. The next pick, you're picking 3, so the next one you pick is gonna be, if you pick again the red one, it means that now you have only 6 red bows remaining, 6, so you can only pick from 6, and the total number has reduced further from 19 to 18. The reason why you are reducing those values is because the question is saying without replacement. So when you pick a bow, you are not replacing that bow, you are not putting it back. So 6, so you will have 8 over 20 plus 7 over 19 plus 6 over 18. When you put those values together, you should get 0.0491. So 0.0491. That should be your probability. Next one, it says all 3 are white. The probability of picking white is 5. So you are doing the same thing, except now that you are dealing with the white bows. You are dealing with the white bows. So it's the probability of picking white, white, white. Okay, so that is going to be that's going to be white bows. There are 5 white bows here, so this is going to be 5. And if you pick another white, there will only remain about 4 white bows. Pick another white, there will remain about 3 white bows. So you are doing the total number will keep on reducing by 1, like that. So this is going to be 4 over 5 plus 4 over 19 plus 3 over 18, and your final answer should be 0.00877. So 0.00877 as your probability. The next one, 2 red and 1 white. 2 red and 1 white. So you're looking at the probability of 2 red, 1 white. You can start by picking white, then you pick red, red. That's 2 red, 1 white. Or the other way this can happen is where you pick red, white, then red. Okay, so you have red, white, then red. That's another way you can pick that. The other way you can pick that is where you pick a red, red, then white. So you pick red, red, then white at the end. So those are the probabilities you have. There was a slight I don't know if you can call it an error in the solution provided. The solution only picked 2, white, red, red, and red, white, red. But there is also the red, red, and white. All right, there is a red, red, and white. All those 3 have got 2 red and 1 white, and those are mutual events. So what you are getting there is a situation where you have so if you have picked white at first, it is 5 out of 20. If you pick red, how many red balls do we have? 8. So you pick 8 out of 19, because the white one you had picked is not replaced. So then the other one is going to be 7, because you had picked a white one, and if you had to pick another white, sorry, you had picked a red, if you had to pick another red, it will be something like that. So that's one of the ways. Or the other way is to to pick red, white, then red. So if you pick red at first, red is 8, so you pick red at first, then you pick white. The white number will be intact, so it is going to be 5 out of 19. Then when you pick red again, remember you had picked red at first, so another red, that is going to be 7 out of 18. The other way this can happen is where you pick red, and then finally white. Red, and finally white. So the other way this can happen is where you have red, and the last one is white. So white is 5 values, 5 white balls, like that. So those are the probabilities you must calculate. So when you calculate those and put the figures together, you must get 0.123. 0.123. That should be your final answer on that one. Remember what I've said, there was an error in the solutions provided for this particular question. The solution had only WRR and RWR, but you must also include RRW. Then the last one, at least one white. So you're looking at the probability of at least one white. So it's gonna be the probability 1 minus every probability that has got no white in it. So it's the 1 so it's gonna be probability of, so at least one white, you're looking at every line that has got no white in it. At least one white. It will be, actually you can do it on the other side by saying total probability, which is 1 minus the probability of red only. So the probability of red only, or the probability of the other color we have here is red only, or the other color is blue, or the probability of blue only. So you eliminate those, the rest of the lines will have at least one white. Okay, so at least the remaining of those values will have one white. Okay, so 1 minus the probability of red only, or you can write it as 1 minus the probability of 0 white, the probability of 0 white. If you're not comfortable working it out like this, you can use the probability trees, but this one will result in 1 minus 0.3664, 0.3664, and when you calculate that, you should get 0.6336. 0.6336. That's the probability for that particular question. All right, so let's get back to the question and see what else we can do. Draw a pie chart to illustrate the cost of the products. Okay, so draw a pie chart. A pie chart drawn in degrees. You have to calculate the degrees, and this is going to be something like the degrees for materials will be 50.4 divided by 119, which is the total, times 360 degrees. So just to show how your table should look like, let me do it here. So the cost items that we have in the question is material, outdoor worker. Let's just make a reference quickly. Material, outdoor worker, trimmings, commission, and fixed expenses. So that one, materials, so material, outdoor. The next one is trimming. The next one there is commission. Then the next one is fixed expenses. So we have the fixed expenses. Okay, so the values are for trimming 50.4. So you have 50.4 divided by 119, which is the total, times 360. So you have to put these ones in brackets. So everything times 360. Why 360? Is 360 degrees. So you'll do the same for the next one. The next one had a value of 37.8. So 37.8 divided by the total, 119. Times 360 degrees. You get to the next one is the next one, trimming is 7. So you do 7 divided by 119, then times the 360. The next one you do is commission, 5.6. So you have 5.6 divided by 119 times 360. The last one you have fixed expenses, that's 18. So you have 18 divided by 119, which is the total, multiplied by 360. So the degrees that you're going to get when you do that, you should get 152.5. The next one you should get 114.4. The next one you should get 21.2. The next one you should get 16.9. And then the other one, the last one, 55.1. So when it comes to drawing your graph, your pie chart is circular. Then you start cutting this into slices. So you have the slice for fixed, which is 50 point something, 55.1. So you cut that one, you write in 51.1, something like that. You write in alright, so you write in 55.1, then you cut another one, you write in 16, dividing it like that. Cut another one, write 16, just like that, until you insert all the values that you need to insert there. Alright, that's how you do the pie chart. Let's go back to the question and see if we can do something more. Alright, so the next question is a little bit longer, so we'll push this one into the next video so that we don't do a very long video. So we end here for now. We will continue revising this question paper in another video.